Craig.
Hi, Paul.
How you doing? Steve referred me to you. So yeah, I just got the lowdown, GPS, lasers. I need to make it all work. So I heard you're the guy to talk to. So basically, there's just tons of trees that we need to map within the city limit. And I would love just to stand in one spot and just, map whatever I see in front of me. So can you just give me a real quick demo of what an offset would look like through the laser GIS?
Sure, Paul, I'd be happy to. Let me turn on my laser. I've got my device right here. I'm just projecting from my device onto the screen so we can all see what I'm doing. Just going to go to the Lasergis toolbar. Go ahead and activate my rangefinder. I get a nice friendly message telling me, hey, you've never set this up before. Let me set it up for you. Turn on. So we should get a connection. We should get some feedback telling us actually who we're connected to. So we see we're connected to the TruePulse. We've got a current version of the firmware. I'll just go ahead and set my target. We're going to map to this observation points. And in this case, let's say we'll start on a known feature, right? You've got a known feature out there that you've already mapped in your map. So I'll go ahead and set my reference point right here. And so we're now locked into this feature. And now I'll just go ahead and shoot my first tree. Let's see, I'll actually remote fire it. So we get our shot come in. That looks acceptable. We'll accept that shot. And so in the background, everything's being filled in for you. All the laser measurements are coming in, your magnetic declination, everything. And then you've got your kind of standard ArcPed edit form comes up.
Okay.
In this case, we're mapping a tree. Say it's good. We'll say OK. And we can see we've mapped this point. So let me just zoom in a little bit. And we'll just wait for the screen to update. And we should be able to see, there you are, and there's the tree captured. So let's shoot another one in another direction. This time I'll manually fire it. We get our shot. That looks acceptable.
Wow, that's pretty slick. So, I was telling Steve, I'm also in task of not only locating the trees, but I got to measure heights. I mean, how would that work? I mean, is that an easy task to do?
Sure. So we've just captured this tree. And now what I'll do is I'll go ahead and put my laser into height mode. Lift this tripod up. And I'll take my 3-shot height routine. So I'll take my first shot, first angle, top angle. I'm being a bit sloppy here. And so we should get a height come back. So Lasergis has accepted our height. And if we look at the feature that you just mapped, you can go to the Identify tool and identify this feature. So you should see the form with what you filled in. But also if you look in the Attributes tab, you can see that your height has come in addition to some other measurements that we've had set up. So your distance, your slope have also been recorded for you. And you can continue and repeat this process for as long as you want until you've captured all your trees.
Okay. Well, what about traversing? A lot of times too, I'm going to have to map underneath some heavy canopy. When you get a good signal, I actually want to traverse in. Could you just do a quick demo of that?
Sure. And just like with the laser offset demo that I just showed you, you could start with an ArcPed map. Or if you're just getting out there with no data, we can also start that way. So I'll just go and show you a quick traverse with the project set up. And I'm just going to say I'm not capturing Z values. We'll just do a simple 2D traverse. In this case, I'm going to get started with the GPS for my first reference point. So I'll go ahead and turn my GPS on. Since it won't work indoors, I've got a fake GPS feed coming in. Okay, so we've got some GPS. And I'll go in and I'll take my first shot. Right. So that shot's come in. I'll accept it. And what's happened is it's taken my GPS point, use it as a reference, move me along to the next point. In the background, it's automatically capturing everything. I don't have to press any buttons. Everything's auto-entered for me. You have to press one button. Everything else is auto-entered for me. And it reminds me to, hey, go ahead and move to your next point. So we can see here's where we shot from. There's where we've captured to. I'll just go ahead and turn off GPS because now we're just going to continue traversing. So you would occupy that point. We'd go and set up my next shot. We'd set up our next shot to go ahead and auto-accept everything. And now we can be in a very productive mode. We can shoot, keep our hands off, let our shot come by. That's right, the emulator's just bouncing things up and down. Let our shot come by, automatically capture it, and take the next shot in the traverse. And we can continue on in this manner. Let me just open a traverse map here so we can see what it'll look like when you're done. So here's a full traverse coming up. So here's an entire polygon traverse that was done by the BLM. And what we can do here is once we're done, we can actually look at the raw data. So we can see all the actual measurements, where the reference points were, see all our shots. And this becomes very valuable in the field because as we go down and look at our traverse towards the beginning here, we can start to see where there's some misclosure. If we zoom in even further, we can really get down there and see where our first shot was and where we came back and finished our traverse. It's a really powerful tool in the field. The last piece of that is actually getting our traverse measurements. So let's do a get length area, tap my feature, and I can see now what the length of that traverse was, what the closed area should be in various measurements, and then really importantly, our traverse closure ratio. So we know right there in the field, hey, you passed or failed, you need to either retraverse or go home.
All right, so I've actually, this seems pretty robust. I've heard of other laser offset, tools out there. Really what's Lasergis? What makes it different?
Sure. So let me talk about kind of some of the basics, right? So it works with all the LTI devices. So any LTI laser it'll work with, and it's based on point-based workflows. So you saw, even though you might be out there doing a traverse of an area or a traverse of a line or trying to capture lines, it makes it much easier to work in a point-based workflow and join these things back up later. So even though we're basing everything on a point-based workflow, that doesn't mean you can't start with lines and polygons that you already may have in your system. So you can go ahead and take any line or polygon layer in the project setup dialog, select it as a template, and Lasergis will create a point-based version with all the same attributes of that for you to use. And as you saw with the traverse, we can get lengths and areas from all types of features, not just polygons and lines. So I can get the length and area of a set of points, I can get the area of a line, had it been closed, and so forth. And finally, what we've done here with Lasergis is Lasergis has a set of tools that are all organized together in one toolbar that override and enhance some of the built-in ArcPad tools to give you some more functionality and a nice, clean workflow.
So speaking of toolbars, go ahead and explain more.
Yeah, and just the type of workflows that it supports. You've kind of seen these, but a traverse type of workflow, whether it be a 2D traverse or even a 3D traverse, like a stream channel. And then offset point feature, so the type of tree capture that you were looking at. Very high productivity, high efficiency, pulling heights in, pulling attributes in. And also if you want to bring things like height and diameter from the laser directly into the attributes, you can bring that in as well.
So speaking of the toolbars, I kind of jumped the gun, but can you walk me through? Is it complicated? Obviously we want to make this thing as simple as for me as possible. So.
Sure. Yeah, I think we've kind of made it so easy that even you can use it, Paul. It's just a small set of tools. It's basically 4 sets of tools plus the ArcPad built-in select editable layer tool. And you typically will work left to right. So you'll start off configuring your project, turning your rangefinder on, setting your preferences, make your layer editable. Then you'll move to setting a reference point. You'll then set up your next shot, and finally fire your laser or use some utilities. So just a few tools. They're all kind of organized in a very logical way.
All right, so let's just say, again, obviously I'm a novice at this. How do I just get started? Can I just start a map? How does that work?
All right, so...
Do I need my own data?
Yeah, so there's a couple ways. As we saw, you can start with an ArcPad map. So if you're already an ArcGIS user and an ArcPad user, you'll check data out of a geodatabase, bring that into ArcPad, use the Lasergis tools on that, check it back in. But if you're just getting started, maybe you don't have any data, we do have this, we have the concept of a quick traverse, but also kind of a quick templates. So we provide a bunch of templates out of the box, some for simple points, 3D points, reference points, plus any layers in your map that are lines or polygon layers will automatically show up to be used as a template. Plus you can browse to any shapefile on your device and use that as a template. So if you have some data in there that may be close to what you want to start mapping, you can get started with one of those templates. And if you're a traditional ArcPad user already, you'll just use your data the same way you do.
Okay. What about just the declination? Steve mentioned the true false. You can set the declination. How do I make sure that gets communicated right on the data question?
That's a good question. Magnetic declination is one of those settings that often confuses users or leads them to getting incorrect data. So we've got some preferences for Lasergis that let you set it up for yourself. Probably best to just kind of jump in and take a look at some of these preferences. All right, so we'll get to your magnetic declination in just a second, but initial preferences, things like what units you like to work in. Right here in the U.S., we like to work in feet. A lot of people work in meters, even in the U.S., but of course internationally. And there's some people who still like to work at inches, yards, would support chains or any of those oddball measurement units yet. Also your height. So if you're doing 3D, you want to be very